Here we are at the back of the truck looking at the rest of the wiring installation for the Gear Vendors Overdrive. It comes with a very good instruction manual for troubleshooting. And I was talking about my gears being off. Well, there's charts in it. You figure out the diameter of your tire, take your tire diameter, figure out your sizing, do a calculator, and it'll give you the diameter. Like mine's a 31.7. I'd ordered it for 355 gears. Well, I pulled it out to see what the teeth was. So it was 14 teeth on the inside and 35 on the speedometer gear. Well, I'm going to have 410s, which calls for 14 teeth on the inside and 36 on the cable. So I just went ahead and ordered me another gear for that. You'll see here the wiring diagram. Very detailed, very instructioned, even colored to what the wires are. On the other side of it, it even has explanation showing how to hook everything up. When I unpack it, it comes with your controller. Comes with a rocker switch. Well, I've already showed you me setting it up for a pull-push on-off switch. It comes with the circuit fuse, or fuse holder for the circuit, with an LED indicator on it. I am going to be changing this out and having a fuse later on in the fuse box, but it'll be down the road. You got the end of the wiring harness that hooks up to the controller. Your red and black wire for power and ground. This wire handles your indicator lamps, which is in this bag, which you've got a red one for off and a green one for on. It handles that. It handles your push. It'll handle my rocker switch. See what else it calls for on here. It has for an automatic mode, which I won't be running. Then you've got the green and purple wire here. This goes to your signal generator here to tell the computer how fast the truck is running. And this red, black, red, white go to the solenoid on the transmission to engage the overdrive. The way this is designed, the overdrive will not engage below 20 miles an hour because it's not building enough pressure to leave the transmission. The way the transmission is, it's basically part of a GM 350 that's been set up to do it. All self-contained. You use GM manual transmission fluid to do this. Now when we get inside and look to where we're going to put the controller and the wiring, you want to think about anything you might be doing in the future. Well, I already know I'm planning on going up under the dash here. Get my light cut on. And you can see the factory fuse box back there. Move these wires out of the way. Well, I just ordered me a 12 circuit fuse box that is going to be used to replace those with regular. This one only has 5. It'll give me 12 because I know later on I'm putting air conditioning on it. I'm going fuel injecting also, so I know that. So when I go to install this and run the wiring under the hood, I want to look at where everything's going to be at. So I want to get out here. I'm going to be using Edelbrock's surge tank, which I'm planning on mounting right in here, and using the factory system because I have dual tanks on the fuel injection. That way I can run low pressure up to it, and then this tank pressurized that will be here will pressurize the fuel and send it over to my fuel rail when I get it there. As you can already tell, I've upgraded the hydro boost. I'll talk more on that later. But I want to look in here and see where's the best place to run the wires through, where can I put the computer. Talking about the air conditioning, I know the compressor goes here on the motor. I know the lines, get around here where I can do it, go through the firewall right in here. There's 2 little nipples. but it's, or more than 2, but it's designed to go through the firewall there. So I know to watch out for that. So when I go back inside, I want to look, because I like to keep all my electronics in the inside the cab where they're away from weather. So I'll look and find a good spot to put this controller. Up under here, which I already see somewhere, but I've also got to look at my computer for the fuel injection and how close I can have the two together because of electronical interference. So I'm going to get off here and see what I can figure out on that and show you when I get it done. Okay, while I'm talking about the fuel injection, I need to go ahead and show you. Let me get this bag open. This is Edelbrock's controller. Comes with a wiring harness, cam lock. It does have oh, now I can't remember the name of it. You can hook up to a separate dash, CAN bus. It's got a TAC output and 2 fan control outputs if you decide to go electric fan. It's got its own power relay. This pink wire goes to the ignition to where when you start it, it comes on. This is the fuse for the computer. This is the power relay. This is your leads for your positive and negative. They have to be hooked to the battery. This is your fuel pump, which that will go to this, which it has its own connector that will plug in to the fitting and then snap on here. This is the surge tank I was talking about. This plug is for your injector harness, which is this one here. Controls all your 8 injectors, your coolant temperature, your air temperature. This is the injectors. Let's see. Throttle position, fuel pressure, and your map sensor, which will plug into this part of the harness. This part of the harness is for your coil, so it will plug into this. This system, the nice thing about it is it comes with a distributor also. You set the timing at 12 degrees when you put it in, and you leave it there. The computer does the rest. This is for your idle air control and your coil. So when I go to put in the gear vendors, I want to look and see where to put this computer and make sure I'm not going to get electrical interference, and try to run all the wires through the firewall in the same place for the best, cleanest look I can. I mean, it's not going to be as clean as it was. I'm adding more wiring than was ever there. So let me get back at it. Okay, found a good place to put it. I made a bracket. Used the bolts here on either end that hold the dash pad on. Made bolted these to a piece of aluminum stock. That way they're out of the way, because I have wipers, this other wiring for the radio and the heater and the main harness going out under the hood. Then when you come around here, you already have wiring coming out at one spot. I may have to make the hole bigger, I don't know, but it puts the unit close enough for the hot wires for the fuel injection to go here. The only thing I'm going to have to do is lengthen the driver for the surge tank that I'm going to mount right here. And my plan on mounting the surge tank, go back here and grab it. It's going to be right in this area, but I really don't want it standing up like so high. So what I'm going to do is figure out how big of a spot I need under it and cut it down, cut the fender well out and drop it down in the fender well a ways. And then I'll had to put brackets on for the mounting bolts up top, but I want it setting flush in there. And then I've got plenty of room up under here, as you can see. Not going to be any tire interference. I will make a sheet metal pan to go around it to block it off to protect it from road debris. And with the transmission controller also up where it is, and the pigtail going this way, I'll be able to run the wiring for it to the shifter, down and out, and to the transmission, and over to the fuse box on the other side. Now that I have the control module mounted, time to start the wiring. Here's some of the tools I'm going to be using. I'll be using a digital ohm meter. I'll be looking for a place to hook the power up to that is only powered when the ignition switch is on. With a voltmeter, you're going to need test leads. I find it's easier to use a clamp on the ground side, that way you're not trying to hold two leads in place, or two test points in place at the same time. You're going to need the lead cables. Once you get done with that, you're going to need a good set of crimpers. I use these to start my crimp with and these to finish because they do a better job. You're also going to need a set of wire cutters, which I've got this set, and these crimpers also have one. You're going to need the wiring diagram. Any other items that come along with it. This is the fuse. Some more, it comes with its own crimp connectors. There's some more that I've pulled out. The indicator lights, the red and the green indicator lights. This is a speed adapter or sensor. It's going to be going under the truck, so you'll have to hook that up. You'll need extra wiring because to extend out the negative and positive, or at least the positive lead, is where I mounted it. It's not close enough to the fuse box to get a power source from it. So I've got a full spool of wire here, and I have some leftover wire from another job that I took out. I'll be using it. You'll need the factory wiring harness, heat shrink, especially if you're putting something under the vehicle that you've crimped, electrical tape, and a torch and a lighter to use on the heat shrink. Okay, back in the cab, you can see I went ahead and plugged the end up to the control module under the dash. I separated out the wires that go to the speed sensor and the solenoid to activate the gear vendors. I've took some zip ties and gone down and zip tied it every so often. My plan is to run it through here behind the dash, come around and down in behind the carpet, and go out around the shifter under the truck. Shortest route possible. At the moment I didn't zip tie it all the way because I don't know how long I'm going to be. I took a little electrical tape and taped the ends together. With that being said, I left a little tab to make it easier to pull the wiring off, or pull the tape off the wiring when I get it there to where I can terminate the ends where I need to be. Okay, I did add another tool, or a couple of tools. These alligator clip holder to hold the wiring and all, and a soldering iron for my on-off, pull on-off switch, or pull-push on-off. I'm using the wiring that come with the switch, the little rocker switch from Gear Vendors, just because it's smaller, it's thinner, and it'll make it cleaner. I've shortened these wires down. As you can see here, they were longer. I'm trying to do a little bit of a cleaner look. I could do the crimp fittings here, but for a cleaner look, it's easier to go ahead and solder it. I've got to go ahead and say that the soldering iron, the solder, and the holder I inherited. Tools that I've had soldering irons, but none of them work good. This one does. I never had this, which I wanted one. I don't like inheriting tools. I'd rather have the person than the tools. And I've got to say a thank you to my brother, James. I hate that he's gone, but he's no longer suffering. So, and that's as far as we'll go. And I've got to, so what we're going to do here is we're going to come in. I've already heated it up. Tinted the tip. I'm going to come in and I'm going to add heat to the wires. Once they heat up, they'll go ahead and solder. You see there, I did remember beforehand to put the heat shrink on here, that way I can run it back over it when I get done. So I'm going to get the other one run and then we'll be back. Okay, I've got both ends soldered, got the heat shrink run down. Now on the first one I had the heat shrink down in this area. Well, the heat from soldering it made it shrink, so I had a real hard time getting it down. So what I did on the next ones, I went ahead and went back and trimmed it and kept it up over this area. Got the alligator clip closer in to try to pull some of the heat out. I still had a little trouble, but nowhere near as bad. I'll get the torch going here. Remember, this stuff is hot. You can burn yourself. The same thing with the same thing with the soldering iron. Heat shrink down, everything's secured good. Soldering iron, you notice I moved it over the side out of the way. Be very careful. You don't want to burn yourself with this, so watch what you're doing. Okay, the switch is mounted back up, which I've got to make a cover or something, go over this and hide it. I'll figure out what I'm going to do. I really want to use a split loom to go down and cover the wire as it goes all the way down and through the shifter boot. The only problem is with this split loom, it's not big enough. So I've got to order, and it's the biggest I've got, so I'll have to get me some bigger. So for right now, what I'm going to do is I'm going to take wire ties and go around it. You want to do something that's going to coordinate. I mean, if you do white, it's going to stick out like a sore thumb. I've got blue, which, you know, again, sore thumb. I've got an assortment of colors here: yellow, green, blue, white. But I've also got just regular black zip ties. So I'm going to use a black zip ties and just start and zip tie it in a few spots to hold it down through here till it goes through, until I can get the split loom that I want to put on there. Okay, here we go. I got the wiring run down through here. Zip ties. I also went ahead up here and just used some electrical tape to clean this up and make it look better. Not a permanent fixture, just till I can get what I want made to cover it. So zip tied, and it runs through the boot, and then I'll run it up under the carpet and back up to the connection. Okay, we're under the truck now, as you can see. The extension housing hooked up to the gear vendors. Now in this part here, there is a sleeve or an adapter. It's wind on both ends, solid in the middle, to connect the output shaft of the transmission to the input shaft of the gear vendor. The other place I had to use the lathe for was on that. From this surface here, where the gasket is, that adapter's supposed to set inside, be flush 0 to 15 thousandths clearance when you go across with a straight edge. Well, mine was plus 50 thousandths out. So what I had to do is go in and machine the inside of the adapter to where I could get it in there, and I ended up with 7 thousandths clearance going back in. So if I hadn't had the lathe, I wouldn't have been able to do this. So if you don't have the equipment, this is not a job I would advise anybody else to start. Then the next thing you have to do is measure for the drive shaft. This one has a carrier bearing because, as you can tell, this is the gear vendors makes the transmission longer. This is where the carrier bearing sits. So what you do is you set up here and you come from the center of these bolt holes to the back of the output shaft, and you measure that, and that will give you the distance from the center of your carrier bearing to have the drive shaft, that part of the drive shaft, shortened. I'm hoping this will help with my gas mileage and my cruise speed. Right now, I was running with a MP435 Granny Gear 4-speed. Final drive was one even in the transmission. The rear end back here has a set of 14 gears in it. I have a set of 354s to go in, but on these Dana 70s, there's different offsets. Well, this rear end has the half-inch offset. The 354 gears you can get are for the 5/8 offset, which means I'm an 1/8 of an inch thicker on the ring gear than I need to be. So what I'm going to have to do is send a ring gear and have it machined down that 1/8 of an inch, or 125 thousandths, which altogether will even help better, because I'll go from 410s to a little over 3, I think it's 319, 320 final drive when the gear vendor's on. Well, if I go to the 354s, I'm under 2, like 2.7 something. I'd have to look at it again before I cut the gear vendor, when I cut the gear vendors on. So it will be, you know, make this truck more street friendly. I've drove this truck already to Pigeon Forge, Tennessee from the coast of South Carolina. So this gear vendor would have been nice to have then. And at a later date, I'm hoping to change out to a Tremec 4050, but they don't make it for this truck yet, which is the replacement for the MV 4500. And it will give me, and then put the gear vendors on the back of it, which will give me a double overdrive. The only issue I'm going to have right now is that I had the speed armor gear in here set up for the 354 gears. I'd already had them ordered, was putting them in, then I found out I couldn't because of the offset. So now I'm going to have to get another gear, speedo gear, to go in here to make sure everything sets up right. So we're under the truck now, getting ready to hook up the signal generator and the solenoid here. Now for the signal generator, you have a couple of pieces. You have this, which is your generator. You have an adapter, which adapts to this speedometer cable into the generator. Calls for a new O-ring here that I've already put on. Then you take the adapter and run it down tight. There is an extension piece you add on to the end of the cable. Then you take the cable and the generator and slide it up in there, which for some reason Maybe I don't need the adapter. Let's try it again. Okay, I didn't need the adapter. So the cable is in, locked in place. I will find somewhere over in here to mount this to keep it away from the exhaust heat. Same thing with the wire. Have our speedometer cable that comes off the gear vendor. Put that in place. I'm going to run it over top of the emergency brake cable. And then hook it into the generator. As it is, it's out of my way right now. In a good spot. I'll come back in a little bit with a mount and just put over it. Get the tape off where I ran it through the floor. And nothing ever comes apart right. My tape job didn't work earlier that I did to try to make this easier to do, as you can tell. Oh, there we go. Look. My plan is to come in up here where my hand's at. There's a screw that holds the hump down in the floor. I'm going to go through the body clip for it with a zip tie and tie both these wires up here like so. This one comes over to the signal generator. I'll be terminating with two female bullets to go with the two males that's on this end. I'm going to shorten the one for the solenoid. I'm going to leave a little bit extra on it. But then it'll come in and get two flat blade males to hold it on here. These are not specific. You can hook them up to either one of the wires on this one. Let me check on the signal generator or the solenoid. Okay. Connected over to a solenoid, no polarity. So I can hook up either wire to either side of this. Well, turn the camera. Either wire to either side of this for this one when I shorten it and put the two spade connectors on the end. Like I said, I want to make sure I keep me some extra wire here, but I'm going to work to keep it up out of the way of the exhaust. And get down, and you can see the wire just runs around the shifter and down here. Okay, I'm hooking up the controller now, sitting here at the back of the truck. I'm going to show you how I'm doing the connections. Take a pair of wire strippers, strip both of the wires back. This is for the green LED. Then I come in with the female spade connector, or the female to accept the spade connector. First, I will go ahead and use these crimpers to crimp it down. I've had problems with these. They're great to strip. They're great to do a first crimp with. But I've had issues with the wires pulling out before, so I bought these Kleins. They're ratcheting. So I put them in. See? I told you that I've had the wires pull out before, and this time it goes to show you. Get this one back in. See, once you get it crimped good, they won't pull back out. See if I can get this to work better this time. Okay, that crimp felt better. Not pulling out, but I still don't want to take the chance with those, so I just come back in with Kleins again. Squeeze it. Time I release it on its own, they'll manually or automatically release, but you can also release them manually. Both are in good. I made a chip to put the LED in, soldered the wires and heat shrink them. Go up here to the front of the truck and show you why I made the little tube. It says to drill a hole, 5/16 hole, to put them in the truck. Well, I didn't want to drill my dash. I didn't want to drill the gauges. So I made this gauge holder already, just some exhaust pipe. So I'm turned down some 1/8" galvanized water pipe. I'll epoxy it here, and then I'll do the same thing with the red one there. And when you look, I crimped these two female spade connectors on this end when I did the wiring. Okay, when I did the wiring on the unit, I wired everything up different ways. This one here that's already connected is the switch for the push-pull. Then, told you I used the females on this end, and I used the male on this end. So this one will be for the green light, and this one will be for the red light. So if I ever have to unplug them, I can just look real quick and see, well, this matching pair matches here, and then I'll have just the opposite here. I'll take some black tape, and I will tape the pairs together to where when you unplug them, it's easy to tell which pair goes with which plug. So it'll be like that in the end on each one. I wired the fuse in with the extension for the hot, and I added a little extension in to where I can hook the ground up in the same place as I have the others. Okay, I come in here to find a power source. I use my voltmeter. Like I said, we've got 5 circuits on this fuse box. Well, you go in and you check each one. And as you see, this one's got power all the time. This one here that I'm checking right now, which the wire for this is the lights for the 2 gauges I added. This is the hot side, this is the cold side. The only time this gets power through it to go through the fuse is when the light switch is on. The gear vendors come with 2 copper pieces, like so. This one is for a spade, for the spade type fuses. The one I've got in here is for the round fuses like I've got. The end of the hot wire has one of the females on it. So it'll just slide right up over this. Now this is just temporary here on both of these. I have a 12 circuit blade style fuse box ordered. I will be taking the factory wiring out of and wiring into it when it comes in. It'll probably be a little bit longer before I get to that. I've got a show I'm planning on taking this truck to in the next couple of weeks. One of the reasons I want to get the gear vendor in, the heads done, and the fuel injection on there before I go out. Now I showed you that one had power on it when the switch was off. Well, now I've got the switch on, and you come in and you check this one, and you have power there. You've got power on the 3 of the others in the circuit, and then here is the one that I told you was for the lights. No power. Pull the light switch on, and you have power. You have power on that even if the lights are on, anytime the lights are on. You would not want to use this for the cruise control, or not the cruise control, but the gear vendors, because you'd only have power to it when you had the lights on, so that'd be defeating the purpose. You don't want to use this one because it's got power on it all the time. So you want to switch power, so I'll be using one of these 3 here to do the job. Now there was one other thing I forgot to mention when I was talking about doing this. By putting this on this side, this is the side that the main power comes in. So if the fuse blows, there's no power on this side. Well, since the gear vendor has its own fuse, you don't want it on the other side of this circuit on the fuse, because then you'd double fuse it, which would be a redundancy. And you don't want the extra current of the gear vendor's pulling, which is only 5 amp fuse in the gear vendor. You don't want that extra current drawing through this fuse. It might cause it to overload and blow, and then you lose more than just that.